We're going to have a look at the Excel formula for sum product. So I have some data here in the upper left-hand corner. Let's say you're in a class where you received the scores listed there, okay, all the way from a 98 up to an 88 for your fifth score. Now, I'm sure you've all been in classes where things were, instead of being equally weighted, they were weighted differently. So, for instance, let's suppose that the last score of 88 is a final exam. Well, some professors might give that a weighting of 50% or 0.5 here. So, maybe this is like a test, a midterm, which is weighted a bit heavier, a test, and then a final exam. The weights here, since they are weights, they need to add to 1, which is the same as 100%. Now, based on this information, if you wanted to figure out what your grade was, your weighted score, you could go through this somewhat laborious calculation, which I'll run through quickly. You could do equals. Now, you could take your first score, 98, click on that cell, B2, and you could multiply it using a Shift 8 by its weight. And then we'd have to continue with the others. So now we do a plus, and we would do the 86 times the 0.1, just clicking on those cells. Again, a plus, the 100 times its weight of 0.2, the 91 times its weight of 0.1, and then plus the 88 times its weight of 0.5. Now notice, you can look up here in the formula box there. So we've got a series of multiplications where the results of those multiplications were added together. Each time we had a plus sign in between. Let's just see what we get as a weighted score. That would be a 91.5. In college, that would typically be an A. Well, the sum product formula allows us to do all that work almost instantly. The word sum, here, let me click back on the 91.5 so we can see it. The word sum refers to the fact that we were adding a bunch of things together, and what we were adding together were products. Product is times. So we do a times, times, a times, a times, a times, and we add all those together. So let's redo it using the sum product formula. Now, to get any built-in formula in Excel, you start with the symbol equals, and you just start typing it. Okay, if I type sum, I'll already see in a drop-down list there, sum product. You can just double-click on it to select it. And then it says array 1, array 2, array 3. Well, what they mean by arrays, it would be these groupings here. So the first array would be the scores. And then the format is you put a comma. And then your second array would be the weights. To be safe, close your formula with a parenthesis. So that sum product will give us the exact same answer. So sum product is just a real handy little tool. Now I'd like to show you some other problems the sum product can be used for, and also, especially in sheets 3 and 4, you'll see there might be some surprises for you even if you already have used the sum product. All right, so here, notice I have this set of cells here. I have them highlighted in yellow, and the values have not been specified. Sometimes when you use an Excel, you may have values you don't know. Kind of think of these as being in algebra, for instance. Maybe this is variable A, or maybe variable X, Y, Z, W, whatever. What the sum product would do is we could use it to set up what, if you recall algebra, it basically is a polynomial. We're going to multiply the 2 times this unknown, the 1 times this unknown, the 6 times this unknown, and so on, and add them all together. So using the sum product, again, even though we don't know these values yet, we would select that first array, we'd do a comma, we'd select the second array, we'd close it with parentheses. Now when we hit enter, we get a 0 there, and that's because when we were multiplying we had zeros there. But just to show that we still have captured the essence of this, let's just kind of play with it a minute. Let's put in a number 8 there for that first variable and then hit enter. Oh, notice it knew we were supposed to multiply the 8 times the 2 there. And let's say we toss in another. How about I'll put in a 4 here. And so this is what it's done. It said, oh, you have an 8 there, so that's 8 times 2 is 16. Now we have a 4 times 3 here, 12. 16 and 12 give 28. And this comes in very handy, well, for instance, if you've watched my videos on linear programming. Very handy there. Let's move to the next example I'd like to show. And some people who have used the sum product don't realize you can also use it for columns here. So here I've specified everything. If we do a sum product, we'll do probably just what you'd imagine. We do 2 times 9 is 18. We do 5 times 2 is 10. 3 times 4 is 12, and so on. And all those things would be added together. So no problem that they're in columns instead of rows like the previous examples. Let's grab our sum product. In other words, an array can be across what we call a row, or it can be down. So we select the first array there, comma, second array, close it with the parenthesis. Well, if we wanted to, we could verify that was correct. And finally, sheet 4 might be more of a surprise. You see here how the first array is actually a rectangle of numbers, as is the second. If you've studied matrices before, it's excuse me, it's not related to the sum product here, okay? I'm not showing a matrix operation. Rather, what sum product will do is it'll say, okay, this 3 here, well, that corresponds to the point 1. So we multiply the 3 times the point 1, and then multiply the 1 times the point 6, the 2 times the point 2, the 0 times the 0.9, 7 times the 0.6, and the 2 times the 0.2. Each of those results then would get summed, that is, added together. So again, start with an equal sign, pull up sum product. I'm double-clicking on it, and your first array would be this block of numbers here. Your second array would be that second block of numbers. As long as when you're doing sum product, the 2 arrays are of the same size or shape, it will work. And there we go. So if you work that out the long way, it would be 5.9. So sum product can be your best friend when using Excel, especially when you have long calculations. That would be tedious to do individually. Okay, signing out, and good luck.